Hello there and welcome. Tonight we are going to explore the night sky together. We will look at the stars, the moon, the planets, and all the beautiful things that shine above us when darkness falls. This is a place for you to relax, to let your mind wander gently, and to drift into peaceful sleep. You do not need to do anything right now except rest. Let your body sink into comfort. Let your breathing slow down naturally. The night sky has been above us for billions of years, and it will be there long after we are gone. There is no rush. There is only the quiet beauty of space and time. If you are here to learn, that is wonderful. If you are here to fall asleep, that is just as good. The stars do not mind either way. They shine whether we watch them or not. Tonight, we are not just reading facts about space. We are drifting through a story that has no ending, a story written in light and darkness across the entire universe. Before we begin, if you enjoy these quiet journeys, you can like this video or leave a comment. What matters is that you are here, breathing slowly, ready to let the wonders of the sky carry you away. So, let us begin this journey together. Let the night sky hold you gently as we explore 100 quiet truths about the universe above. Fact 1. Every star you see with your eyes alone belongs to our own galaxy. When you step outside on a clear night and look up, you might think you are seeing the whole universe. But the truth is softer and stranger than that. Every single point of light you can see without a telescope is part of our home galaxy, the Milky Way. Scientists believe that under perfect conditions, the human eye can see about 6,000 stars across the entire sky. So what we see is just the tiniest piece of our cosmic neighborhood. We are looking at our own family of stars, scattered across the darkness like glowing seeds. Fact 2. Some stars in the night sky are already dead, but their light is still traveling toward us. Light moves fast, faster than anything else in the universe. But space is so huge that even light takes a long time to cross it. When you look at a star, you are seeing it as it was many years ago, maybe hundreds or even thousands of years ago. The light you see tonight left that star long before you were born. Some of those stars have already burned out or exploded. They are gone now, turned into clouds of gas or collapsed into something strange and dense. But their light keeps moving through space, crossing the emptiness, still reaching us as if nothing has changed. The night sky is not showing us the present moment. It is showing us a moving picture of the past, layer after layer of history. Written in starlight. Fact 3. Polaris has not always been the guiding star of the north. For people living in the northern half of the world, Polaris is special. It sits almost directly above the North Pole, so it marks true north in the sky. Travelers have used it for centuries to find their way. But Earth wobbles slowly as it spins, like a top that is starting to slow down. This wobble is called precession, and it takes about 26,000 years to complete one full cycle. Because of this wobble, the stars slowly shift their positions relative to our poles. Polaris has not always been our North Star, and it will not stay that way forever. Thousands of years ago, in the time of the ancient Egyptians, a different star called Thuban held that position. In about 12,000 years from now, a bright star named Vega will become the new North Star. The sky is always changing, just very slowly. Fact 4. Ancient travelers used the stars to cross oceans and deserts. Long before anyone invented maps or compasses or satellites, people looked up at the sky to find their way. Sailors crossing the huge Pacific Ocean memorized the patterns of stars and used them as guides over the water. Desert travelers did the same, watching the stars to know which direction to walk. Polaris helped people in the north find their way, and in the southern half of the world, people used a group of stars called the Southern Cross. Entire systems of knowledge grew around watching the sky. The Polynesian people, for example, remembered the positions of hundreds of stars and passed that knowledge down through stories and songs. These star maps were more than just tools. They were treasures, pieces of culture that could never be lost. Fact 5. The Milky Way appears as a cloudy band because we are looking through the middle of our galaxy. It looks like a river of mist or a glowing path. This is the Milky Way, and its glow comes from billions of stars that are too far away to see individually. The reason it forms a band is because we are inside the galaxy, looking through its flat disk. Imagine standing inside a giant spinning wheel and looking toward the edge. That is what we are seeing from Earth. All those stars, clouds of gas and dust in the disk blur together into one hazy strip of light. Some called it a river in the sky, others called it a road for spirits. Today we know it is the plane of our galaxy, and every tiny glow in that band is another Sunday. Fact 6. Our galaxy contains hundreds of billions of stars we cannot see. The stars you see at night are only a tiny sample of what is really out there. Astronomers think the Milky Way has somewhere between 200 billion and 400 billion stars. Most of them are too dim or too far away for us to see without telescopes. Many are red dwarfs, which are small and faint compared to our Sun but extremely common. Others are hidden behind thick clouds of gas and dust. Scientists can only see them using special instruments that detect infrared light. There might also be countless planets wandering alone through the darkness, not circling any star at all. When you look at a sky full of a few thousand visible stars, remember that what you see is just a pinprick compared to the full population of our galaxy. There are so many suns out there that no one could ever count them all, not even in a whole lifetime. Fact 7. Shooting stars are not stars at all, but tiny pieces of dust burning up. When you see a streak of light flash across the sky, it feels magical. People call them shooting stars, but they are not stars. They are usually small fragments, often no bigger than a grain of sand or a pebble. These bits of cosmic dust are flying through space at incredible speeds. When they hit Earth's atmosphere, the air in front of them gets squeezed and heats up, and the dust begins to glow. Most of them burn up completely before they ever reach the ground. What we see is their final moment, a bright flash as they disappear. Some of these fragments come from comets that passed by Earth long ago, leaving trails of debris behind them. Others are just random bits of rock and metal drifting through the solar system. They may be tiny, but the speed and heat make them shine brilliantly for just a second before they are gone forever. Fact 8. From the darkest places on Earth, thousands more stars become visible. Most of us live under skies filled with artificial light. Streetlights, buildings, and glowing cities wash out the stars and make the night sky look empty. But in rare places where there is no light pollution, the view is completely different. In deserts, on mountaintops, or on remote islands, the sky comes alive. The Milky Way becomes a thick, glowing band stretching overhead, so bright it can even cast faint shadows on the ground. In these dark skies you can see blurry patches that are actually distant galaxies, clusters of stars packed together, and sometimes even the soft colours of nebulas. Astronomers call these places dark sky sanctuaries, and they are becoming harder to find. To stand beneath one of these skies is to see what every human before the invention of electric lights once saw every night. Fact 9. Some places never see the Milky Way anymore because of light pollution. For many people around the world, the Milky Way is not part of their life. In big cities and crowded areas, the glow from artificial lights has erased it from view completely. Whole generations of people grow up without ever seeing that river of stars that once meant so much to human culture. Light pollution does not just make the stars harder to see. Cities that stay lit all night send light upward into the atmosphere, creating a permanent orange or yellow haze. As a result, in some parts of the world, the Milky Way has effectively disappeared. But the stars are still there, hidden behind the veil of our own lights. People are working to protect dark skies, not just for science but for wonder. Seeing the Milky Way with your own eyes connects you to something ancient and universal. Fact 10. Constellations slowly change shape over thousands of years. Constellations feel permanent, like pictures drawn in the sky that never change. But the truth is that every star is moving. Each one travels through the galaxy on its own path, circling the center at its own speed. Because stars are so far away, we do not notice their movement during our lifetimes. But over tens of thousands of years, the familiar shapes we know begin to shift and stretch. The 3 stars that make up Orion's belt will eventually lose their straight line. The Big Dipper will no longer look like a dipper. Scientists can use computers to show what the sky will look like in the distant future, and the constellations are almost unrecognizable. The night sky is not a frozen picture. It is a slow dance, and the patterns we see today are just one frame in a much longer story. Fact 11. The southern hemisphere reveals constellations that northern eyes never see. If you grow up in the northern half of the world and then travel south of the equator, the night sky will look strange and new. Familiar constellations like the Big Dipper disappear below the horizon. Nearby, you can see 2 fuzzy clouds called the Magellanic Clouds, which are actually small galaxies orbiting our own. The southern sky has its own constellations with names and stories that people in the north have never heard of. For those who live in the southern hemisphere, these stars are as familiar as Orion is to the north. The sky is shared by everyone on Earth, but what we see depends entirely on where we stand. Half the planet sees one view, and the other half sees something completely different. Fact 12. The Andromeda Galaxy is faintly visible without a telescope. Most galaxies are so far away that you need powerful telescopes to see them. But there is one galaxy close enough that you can see it with just your eyes. Andromeda appears as a tiny fuzzy blur on dark nights, more like a smudge of light than anything solid. Andromeda is a spiral galaxy like our own, filled with perhaps 1 trillion stars and stretching more than 200,000 light-years across. The light from Andromeda has been travelling for over 2 million years to reach Earth. Ancient people saw it too, long before telescopes existed, and wrote about it as a mysterious cloud among the stars. To realize that you can step outside and see another galaxy with your eyes alone is humbling. That faint patch of light is not just one object. It is an entire universe of suns, planets, and mysteries. Fact 13. The light from Andromeda began its journey more than 2 million years ago. When you look at the faint glow of the Andromeda Galaxy, you are looking into the deep past. The light you see tonight left Andromeda over 2 million years ago. Back then, Earth was a very different place. Early human ancestors were just beginning to walk upright and use simple tools. There were no cities, no written language, no technology. Entire species have come and gone in the time it took for that light to cross the emptiness of space. While we are seeing Andromeda as it was in the ancient past, the galaxy itself has kept moving, changing, and forming new stars. In about 4 billion years from now, Andromeda and the Milky Way will collide and merge into one giant galaxy. For now, the light from its stars serves as a living record of the past, carrying history across unimaginable distances. Fact 14. The night sky once held stars that no longer exist today. It is easy to think of stars as permanent lights that will shine forever. But stars are born, they live, and they die. Because starlight takes time to reach us, some of the stars recorded by ancient astronomers have since disappeared. Scientists studying old star charts sometimes find descriptions of bright stars that are no longer visible in the sky today. These stars might have been massive giants that ran out of fuel and exploded in supernovas, leaving only faint remnants behind. Others may have collapsed into neutron stars or black holes, invisible without special instruments. The sky is constantly renewing itself, with new stars being born in clouds of gas and dust even as old ones fade away. What we see above us is not a permanent picture. It is a changing story, and every glittering point is temporary, even though it might last far longer than we ever will. Fact 15. A star's colour reveals its temperature. Not all stars shine the same way. Some glow with a soft orange or red light, while others shine with a bright blue or white brilliance. The colour of a star tells you how hot it is. Red stars are cooler, with temperatures of only a few thousand degrees. Blue stars are much hotter, blazing at tens of thousands of degrees. Our own sun sits somewhere in the middle, shining with a steady yellow-white light. Astronomers use these colours like clues. By studying the light from a star, they can measure its temperature, figure out what it is made of, and even tell how fast it is moving. To the human eye, the colours of stars can be subtle and hard to notice. But if you look carefully on a clear night, you can sometimes spot them. Each colour tells a story about the star's energy and its place in the long life cycle of the universe. Fact 16. Stars appear to twinkle because of Earth's atmosphere. When you look at a star, it seems to shimmer and flicker, almost as if it is alive. This twinkling can feel magical, but it is actually caused by our own atmosphere. As starlight travels down through the layers of air above us, it bends and shifts slightly because of changes in temperature and density. This makes the light appear to jump around or flicker, even though the star itself is shining steadily. Planets usually do not twinkle as much because they are closer to us and appear as small disks rather than single points of light. Astronomers call this effect scintillation, and it is the reason ground-based telescopes can never get a perfectly clear view of the stars. That is why many telescopes are built on high mountains where the air is thinner, or even sent into space to avoid the atmosphere entirely. What looks like a playful sparkle is really a reminder of the restless blanket of air we live beneath. Fact 17. In space, stars shine with steady clarity. Astronauts aboard the International Space Station, or spacecraft travelling beyond Earth, see stars very differently than we do. Without the constant interference of the atmosphere, starlight arrives in perfect beams that do not waver or flicker. Instead of twinkling points, stars appear as sharp, steady jewels against the blackness. This clarity is one of the reasons space telescopes like Hubble can capture such detailed images. Freed from the atmosphere, they can see the universe as it truly is. The steady glow in space also reveals the colours of stars more vividly than we usually see from the ground. While twinkling might feel romantic, the view from orbit shows the sky in its raw, undisturbed form. It is a reminder that our atmosphere both protects us and gently hides the true face of the cosmos. Fact 18. Some stars grow hot enough to fuse helium and carbon deep inside. Stars create energy through nuclear fusion, which is the process of squeezing smaller atoms together to make larger ones. For most of its life, a star fuses hydrogen into helium. But massive stars do not stop there. As their cores grow hotter and denser over time, they begin fusing helium into carbon and oxygen, and even heavier elements beyond that. This process builds the ingredients that make up planets and life itself. Every atom of carbon in your body and every molecule of oxygen you breathe was created inside a star that once burned brightly in the sky. When these massive stars finally reach their limits, they collapse and explode, scattering all those elements into space. Those scattered materials go on to form new stars, new planets, and eventually new life. The universe is like a great recycling system, with each generation of stars creating the building blocks for the next. Fact 19. Sirius blazes as the brightest star in the night sky. There is one star that outshines all the others. Sirius, also known as the dog star, dominates the winter sky with its brilliance. It is found in the constellation Canis Major and shines almost twice as bright as the next brightest star. Its name comes from an ancient Greek word meaning glowing, and it has earned that name. Part of the reason Sirius is so bright is because it is close to us. It lies only about 9 light-years away, making it one of our nearest neighbours. But it is also naturally luminous, shining more than 20 times brighter than our Sunday. Ancient Egyptians watched for the rising of Sirius and linked it to the flooding of the Nile River. Today, it is still one of the most reliable markers in the sky, easy to spot even from cities. Sirius also has a faint companion star, a white dwarf that orbits it every 50 years. The dense core of a star that died long ago. Fact 20. Sirius has inspired myths across nearly every culture. From ancient Mesopotamia to the islands of the Pacific, Sirius has been more than just a bright point of light. It has been a symbol, an omen, and a guide. The Egyptians tied its yearly appearance to the flooding of the Nile, which brought water and life to their farmlands. The Greeks connected it with heat and madness, giving us the phrase dog days of summer. In Polynesian navigation traditions, Sirius was an essential star for long ocean voyages. Indigenous peoples of North America included it in their legends and used it to mark the changing seasons. Across the world, different cultures recognized its brilliance and gave it meaning. That one star could mean so many different things to so many people shows its power. It is just a ball of burning gas, but its place in human imagination has made it one of the most enduring symbols in the sky. Fact 21. The Pleiades cluster sparkles like a tiny swarm of fireflies. The Pleiades, sometimes called the Seven Sisters, is one of the most loved sights in the night sky. This small cluster of stars sits in the constellation Taurus and is visible even in areas with some light pollution. Most people can see 6 or 7 stars with their eyes alone, though the cluster actually contains hundreds. If you look at it through binoculars, the view becomes magical. Each star is a young, hot blue sun burning brightly. Ancient cultures all over the world recognized the Pleiades and wove them into stories about family, pursuit, and loss. The Japanese name for the cluster is Subaru, which is now the logo of a car company. The Pleiades are relatively close to us, only about 400 light-years away, and they are still surrounded by faint clouds of dust that reflect their light. They remind us that not all beauty in the sky is distant or hard to find. Fact 22. The Orion Nebula glows faintly within Orion's sword. If you trace the shape of the constellation Orion, you will notice a short line of stars hanging below his famous belt. This is called Orion's sword. In the middle of that line is a fuzzy patch of light that you can see with your eyes alone on dark nights. This is the Orion Nebula, one of the brightest and closest places where new stars are being born. Through binoculars or a small telescope, it transforms into swirls of glowing gas lit up by young stars. Scientists estimate that thousands of stars are forming there right now, shaping the clouds with their energy and light. To ancient stargazers, the Orion Nebula was just a mysterious blur. But today, we know it as a place where the story of stars begins. It is only about 1,300 light-years away, which is very close in cosmic terms. Every time you look at it, you are watching creation in progress. Fact 23. Some nebulas shine because their gases are energized by nearby stars. Nebulas are enormous clouds of gas and dust that stretch for many light-years across space. Some of them glow brightly because powerful radiation from nearby stars energizes them. Ultraviolet light pours out from these massive suns and strikes the atoms in the nebula, causing them to emit colorful light of their own. These are called emission nebulas, and they paint the sky with shades of red, green, and blue depending on what elements are inside them. The Orion Nebula is one famous example, glowing with a pinkish light that comes from hydrogen gas. Without the stars that energize them, these clouds would be dark and invisible, lost in the blackness of space. Instead, they shine as brilliant beacons, marking regions where new stars are being born and where energy and gravity are shaping the raw materials of creation. Fact 24. Other nebulas glow only by reflecting starlight, like cosmic mirrors. Not all nebulas create their own light. Some simply reflect the brilliance of nearby stars, shining in a softer, gentler way. These are called reflection nebulas, and they often have a distinctive blue color. Dust grains within the nebula scatter starlight the same way Earth's atmosphere scatters sunlight to make our sky look blue. One famous example is the faint blue glow surrounding the Pleiades star cluster, where bright stars illuminate nearby clouds of dust. These nebulas are like mirrors in space, catching light and redirecting it across the void. They often appear near young star clusters, where there are plenty of hot, bright stars available to light them up. Though less dramatic than the glowing emission nebulas, reflection nebulas are beautiful in their own quiet way. They are whispers compared to the others' shout, faint but delicate in their shimmer. Fact 25. Many stars are not single but exist in pairs orbiting each other. When you look up at the night sky, it is easy to imagine each star as a lone sun like ours. But the truth is that many stars are not alone. Binary systems, which are pairs of stars orbiting around a shared center of gravity, are incredibly common. Some binary stars are nearly equal in size and mass, dancing around each other in graceful balance. Others are mismatched, with a massive star pulling a smaller companion in wide loops through space. To the naked eye, many of these pairs appear as a single point of light because they are so close together or so far away, but with telescopes, astronomers can separate them or detect their presence through the gravitational pull they have on each other. These binary systems might not be rare at all. In fact, they may actually be the norm in our galaxy. Our sun, shining alone, could be the exception rather than the rule. Binary stars remind us that even in the loneliness of space, companionship is common. Fact 26. Binary systems are more common than solitary suns like ours. It might seem natural to assume that most stars are like our sun, alone with planets circling around them. But surveys of the galaxy suggest the opposite is true. Binary and multiple star systems may actually outnumber single stars. In some cases, stars form together from the same cloud of gas and dust, locked into gravitational bonds that last for billions of years. In other cases, stars capture each other later, through close encounters in crowded regions of space. Binary systems can be peaceful, with both stars orbiting quietly for eons, or they can be violent and dramatic. A massive star can pull material away from its smaller partner, creating swirling disks of hot gas. One star might collapse into a white dwarf, neutron star, or black hole, completely changing the relationship between the two. For any planets that might exist in these systems, life would be very different. Imagine a world with two suns setting at different times, or a place where dawn arrives twice each morning. Fact 27. There are even triple and quadruple star systems bound together. If two stars orbiting each other seems complicated, nature goes even further. Some systems contain 3 or even 4 stars, all bound together by gravity in complex arrangements. In a triple star system, 2 stars might orbit closely while a third circles farther out, like dancers moving in nested patterns. In quadruple systems, the arrangements become even more elaborate, with pairs of stars orbiting other pairs. To our eyes, they may look like a single point of light in the sky, but telescopes reveal the truth, showing a miniature galaxy of suns all connected. Sunrises and sunsets could involve multiple suns casting overlapping shadows and creating floods of shifting light throughout the day. These systems remind us that the cosmos is endlessly creative, building arrangements far beyond what feels familiar. While our single sun seems normal to us, elsewhere in the galaxy, entire solar systems live under the glow of several suns at once. Fact 28. Cepheid variable stars pulse rhythmically like cosmic lighthouses. Some stars do not shine with steady brightness. Cepheid variables expand and contract in a regular rhythm, causing their light to brighten and fade in cycles that can last days or weeks. To the naked eye, they appear to flicker over time, scales much longer than the quick twinkling caused by our atmosphere. The period of their pulsation is directly connected to their true brightness. By measuring how quickly they pulse and comparing it to how bright they appear from Earth, scientists can calculate exactly how far away they are. This discovery, made in the early 20th century, gave astronomers the ability to measure the vast distances to nearby galaxies. Cepheids became like mile markers scattered through space, showing us the true scale of the universe. What began as the curiosity of a star that seemed to breathe in and out became one of the most important measuring sticks in all of astronomy. Fact 29. These pulsations once revealed the true scale of the universe. For centuries, nobody knew how big the universe really was. Were the stars just beyond our reach, or were they unimaginably distant? Cepheid variable stars provided the answer. In the 1920s, astronomer Edwin Hubble studied Cepheids in the Andromeda galaxy. By measuring how fast they pulsed, he determined their true brightness, and from that he calculated their distance. The result was shocking. Andromeda was not part of the Milky Way at all. It was another galaxy entirely, sitting far beyond the edges of our own. The discovery expanded the known universe overnight, transforming it from a single island of stars into a cosmos filled with countless galaxies. Cepheids were the key to unlocking this knowledge. These simple, rhythmic beacons bridged the enormous gulf between us and the wider universe. Even today, with all our advanced technology, Cepheids remain essential for measuring cosmic distances. Each pulse is like a heartbeat of the cosmos, steady and reliable. Fact 30. Some stars balloon into red supergiants hundreds of times larger than the Sunday. Some, when they approach the end of their time, swell up into enormous red supergiants. Despite their size, their outer layers are thin and glow with a deep red colour as the star struggles to hold itself together against the pull of gravity. Inside their cores, they fuse heavier and heavier elements in a desperate effort to maintain balance. These giants burn through their fuel at incredible rates, living fast and dying young. They are rare compared to smaller stars, but impossible to forget once you see them. Looking up at a red supergiant is like watching a dying star in its final chapter. Swollen and unstable, moving inevitably toward collapse. Fact 31. Betelgeuse in Orion is nearing the end of its life. High in the winter sky, the constellation Orion stands out clearly. At his shoulder burns Betelgeuse, a ruby-red star that has fascinated people for centuries. Betelgeuse is a red supergiant, swollen to hundreds of times the size of our Sunday. Astronomers know it is approaching the end of its life. It has already exhausted the hydrogen that once powered it, and now it fuses heavier elements deep inside its core. Sometimes it dims so noticeably that people around the world begin to wonder if it is about to explode. Although it returned to its usual brightness, the event reminded everyone of its fragile state. Betelgeuse is a star in its twilight. Its fate is already decided. Whether it lasts another 100,000 years or only a fraction of that time. Fact 32. Betelgeuse may one day explode as a supernova, visible even in daylight. When Betelgeuse finally reaches the end, it will not fade quietly into darkness. It will explode as a supernova, a detonation so powerful it will outshine every other star in the night sky. For weeks or even months, the light from its death could be visible during the day, appearing brighter than the full moon. Such events have happened before in recorded history. Ancient astronomers wrote about sudden new stars appearing in the sky when nearby stars collapsed and exploded. Betelgeuse lies about 600 light-years away from us. That is close enough for us to witness the brilliance of its death, but far enough away that Earth will be perfectly safe. The explosion will leave behind a dense remnant, perhaps a neutron star, while its outer layers scatter across space, enriching the cosmos with elements like oxygen and iron. When it happens, people everywhere will look upward and see the same brilliant beacon shining down, a reminder that even stars live and die in extraordinary ways. Fact 33. Supernovas can briefly outshine entire galaxies. The death of a massive star is among the most violent events in the universe. In a supernova, the collapsing core rebounds with such tremendous force that the entire star is blown apart in a single instant. For a brief time, the explosion can release more energy than all the other stars in a galaxy combined. From Earth, such events may appear as sudden bright stars, where none existed before. Some fade within weeks, while others linger for months. Beyond their beauty and drama, supernovas serve as cosmic engines. They scatter the elements, forged inside stellar hearts, out into the surrounding space. Without them, the building blocks of planets and life would not exist. The brilliance of a supernova is fleeting, but its legacy lasts forever. To imagine an entire galaxy overshadowed by the death of a single star is to understand both the power and the impermanence written into the fabric of the cosmos. Fact 34. The Crab Nebula is the remnant of an explosion recorded by ancient astronomers. In the year 1054, observers in China and across the world recorded the sudden appearance of a dazzling new star. It shone so brightly for weeks that people could see it even during the day before it gradually faded from view. Today, We know that event was a supernova, the death of a massive star. The remnant of that explosion still lingers in the sky, known as the Crab Nebula. Through telescopes, it appears as a tangled web of glowing threads, the expanding shell of gas and dust thrown off by the explosion. At its centre sits a pulsar, the collapsed spinning core of the original star, still sending out pulses of radiation like a lighthouse in space. The Crab Nebula is a bridge between ancient history and modern astronomy. When we look at it, we are seeing both the memory of a star's death and the continuing life of what remains. Fact 35. Pulsars spin with such precision they rival atomic clocks. Pulsars are among the strangest objects in the universe. They are the collapsed cores of massive stars left behind after supernova explosions. Made almost entirely of neutrons, they are unimaginably dense. A single teaspoon of pulsar material would weigh as much as a mountain. Many pulsars rotate at astonishing speeds, sending beams of radiation sweeping across space like the beams of a lighthouse. From Earth, these appear as regular pulses of light or radio waves. Each pulse arrives with such reliability that astronomers can use them as cosmic clocks. Some pulsars spin dozens of times per second, while the fastest known rotate hundreds of times each second. Scientists use them for measuring distances in space and testing the laws of physics. These tiny collapsed remnants show us that time itself can be written in starlight. Fact 36. Magnetars wield magnetic fields trillions of times stronger than Earth's. Among the many exotic remnants of dead stars, magnetars stand apart. Like pulsars, they are neutron stars, but they possess magnetic fields so intense they are almost impossible to imagine. A magnetar's magnetic field is trillions of times stronger than Earth's, powerful enough to distort the shapes of atoms themselves. These fields can twist and snap violently, producing bursts of high-energy radiation that ripple across space. Astronomers detect them as sudden flares that are brief but incredibly powerful. Though magnetars are small, only about 20 kilometers across, they contain the mass of several suns compressed into that tiny space. Their strength makes them dangerous even at great distances. If a magnetar existed close to Earth, it could wreak havoc on our planet's magnetic field and atmosphere. Instead, they remain distant curiosities, extreme laboratories where the rules of physics are pushed to their absolute limits. Fact 37. Black holes hide in the night sky, revealed only by their effects. A black hole is not something we can see directly. Its gravity is so strong that not even light can escape from it, which makes it invisible against the darkness of space. Matter spiraling into a black hole heats up to extreme temperatures and glows brightly in X-rays before vanishing forever. Stars caught in their gravitational pull may orbit unseen companions, revealing the black hole's mass through their motion. Even space itself curves inward around black holes, bending the paths of light that pass nearby. To the naked eye, black holes are invisible, but through telescopes and careful observation, astronomers have found many scattered throughout the galaxy. Some are the remnants of massive stars, while others lurk at the hearts of galaxies. They are the unseen anchors of cosmic drama, reminding us that the most powerful forces in the universe often hide in silence and shadow. Fact 38. Some black holes consume nearby stars and flare brightly as they feed. When a black hole orbits close to a companion star, it can slowly pull matter away from its neighbour. Gas from the star spirals inward, forming what is called an accretion disk, a whirling ring of material heated to millions of degrees. This process produces powerful emissions of X-rays, making the otherwise invisible black hole one of the brightest objects in the sky at those wavelengths. To an observer with the right instruments, it looks like a flickering beacon, sometimes growing brighter and sometimes fading as the flow of matter changes. In extreme cases, black holes emit jets of material travelling near the speed of light, blasting across space for thousands of light years. Though the idea of a star being consumed sounds catastrophic, it is actually part of the cosmic cycle, redistributing matter and energy throughout the galaxy. These dramatic systems reveal that black holes are not simply voids of emptiness, but active players in shaping the universe around them. Fact 39. The heart of our galaxy conceals a supermassive black hole. At the very center of the Milky Way sits an invisible giant called Sagittarius A star. This is a supermassive black hole with a mass millions of times greater than our Sun. Though it cannot be seen directly, its presence is revealed by the orbits of stars whipping around it at incredible speeds. In 2019, astronomers captured its shadow for the first time using a network of radio telescopes spanning the entire globe. The image showed a glowing ring of light, matter heated to extreme temperatures as it spirals inward, surrounding a dark center where light itself cannot escape. Supermassive black holes like this one are thought to exist at the centers of most galaxies, shaping their growth and evolution through gravity and energy. That our own galaxy is anchored by such a force is both humbling and inspiring. It is the silent heart of the Milky Way, unseen yet profoundly influential. Fact 40. Beyond our sight, the night sky holds countless galaxies. The stars we see overhead may feel abundant, but they are only the beginning. Beyond the Milky Way, countless galaxies fill the universe. Each one contains billions, sometimes trillions of stars. With telescopes, faint smudges of light resolve into spirals, clusters, and smooth ellipses, entire island universes scattered across the cosmos. The Hubble Space Telescope once pointed at a seemingly empty patch of sky and stared for days. It revealed thousands of hidden galaxies in a space no larger than a grain of sand held at arm's length. This discovery showed that wherever you look, even in the darkest corners, the universe is overflowing with galaxies. To the naked eye, only a few like Andromeda or the Magellanic Clouds can be glimpsed. But with the right tools, the blackness between stars transforms into an ocean of light, stretching to the edges of the observable universe. Fact 41. Through telescopes, galaxies appear in spirals, ellipses, and chaotic forms. Galaxies are not all alike. Some form graceful spirals with sweeping arms of stars curving outward from a bright core. Others are smooth and featureless ellipses, vast collections of ancient stars glowing faintly. Still others are irregular in shape, their forms distorted by collisions with neighbors or bursts of violent star formation. Each type tells a different story about its history. Spiral galaxies are active and full of young stars and gas. Elliptical galaxies are older and quieter, often the result of mergers between smaller galaxies. Irregular galaxies are the misfits, still settling into their final shapes. Some shine brightly across millions of light years, while others appear as faint smudges barely visible even with powerful instruments. Yet every one is a universe of its own, containing stars, planets, and mysteries beyond counting. Fact 42. Some galaxies collide and merge in slow-motion dances. Though the distances between stars within a galaxy are immense, galaxies themselves are not so isolated. They are bound together by gravity into clusters and groups, and their paths often cross. When galaxies collide, it is not an explosive crash like cars hitting each other. Instead, it is a slow-motion dance lasting hundreds of millions of years. Their stars mostly pass by one another without touching, but their clouds of gas and dust do collide, triggering enormous bursts of new star formation. Gravity stretches their shapes into spirals, long tails, and graceful arcs. Over vast stretches of time, the galaxies merge completely, becoming one larger system. Our own Milky Way is destined for such a fate. In about 4 billion years, it will merge with the Andromeda Galaxy. Far in the future, the two will become a single massive elliptical galaxy. For now, we watch others in the distance, their cosmic dances frozen in time. Fact 43. The Magellanic Clouds are two satellite galaxies visible in southern skies. From the southern hemisphere, two faint cloud-like patches of light hover near the Milky Way. These are the large and small Magellanic Clouds, dwarf galaxies that orbit our own. To the naked eye, they appear as subtle smudges against the darkness, but through telescopes, they reveal themselves as bustling systems filled with stars, clusters, and glowing nebulas. They are irregular in shape, distorted by their gravitational dance with the Milky Way. Within them lie stellar nurseries like the Tarantula Nebula, one of the most active star-forming regions known to science. For observers in the northern hemisphere, the Magellanic Clouds are invisible, forever hidden below the horizon. For those in the south, they are familiar companions, woven into cultural traditions for centuries. These small galaxies are reminders that the Milky Way is not alone, but part of a larger family of galaxies orbiting, merging, and influencing one another across cosmic time. Fact 44. Star clusters are like glittering families bound by gravity. Not all stars live in isolation. Many are born together in groups called star clusters, held together by gravity. These clusters can range from small gatherings of a few hundred stars to massive groups containing thousands. Open clusters like the Pleiades are loose and youthful, their stars still close to the clouds where they were born. Globular clusters, by contrast, are dense spherical collections of ancient stars tightly packed into dazzling balls of light. To the eye, star clusters appear as sparkling knots brighter than the surrounding stars. Through telescopes, they explode into fields of brilliance, each point of light a sun with its own story. Clusters are laboratories for astronomers, offering insights into how stars form and evolve. To stand beneath a dark sky and glimpse one is to see a family of stars still holding together, bound by forces that have lasted for billions of years. Fact 45. Globular clusters can hold hundreds of thousands of suns. Globular clusters are among the most spectacular sights in all of astronomy. These spherical collections can contain hundreds of thousands, sometimes even millions of stars packed into a region only a few dozen light-years across. In their centers, the concentration of stars is so great that they appear to blur together like a swarm of fireflies. Most globular clusters orbit the outer regions of galaxies. Our Milky Way has more than 100 of them circling its edges. They are ancient, often more than 10 billion years old, containing some of the oldest stars in existence. To the naked eye, they may look like faint fuzzy patches in the sky. But telescopes reveal them as dazzling globes of light, each one containing more stars than you could ever count. Globular clusters are fossils from the early universe, survivors from the time when galaxies were first forming. Fact 46. Some of these clusters are nearly as old as the universe itself. Globular clusters are time capsules that preserve the earliest stars ever formed. Many are nearly as old as the universe itself, dating back more than 12 billion years. These ancient stars contain very few heavy elements, reflecting a time before supernovas had enriched the cosmos with the ingredients needed for planets and life. To study them is to look back into a nearly primordial universe when stars were first igniting in the darkness. The fact that these clusters still exist today, orbiting the edges of galaxies like ours, shows their incredible resilience. They have survived countless galactic mergers, collisions, and gravitational disturbances, yet they remain intact. You are witnessing relics from the very dawn of time, glowing beacons that have endured almost as long as the universe itself. They are among the oldest living witnesses to creation. Fact 47. Meteor showers return every year as Earth crosses comet trails. Several times a year, Earth passes through streams of debris left behind by comets. As our planet moves through these trails, countless tiny particles enter our atmosphere and burn up, creating meteor showers. Unlike random shooting stars that appear sporadically, the Perseids, Geminids, and Leonids are some of the most famous showers, each linked to a parent comet or asteroid. These showers are predictable, returning on the same dates year after year as Earth revisits the same orbital paths. For stargazers, they are among the most rewarding events to witness, filling the sky with fleeting streaks of light. Though the individual meteors are often no larger than grains of sand, their fiery trails remind us that Earth is constantly moving through a living solar system, crossing paths with the remnants of ancient wanderers. Fact 48. The Perseid meteor shower in August is among the most famous. Every August, the Perseid meteor shower fills the skies with some of the most reliable displays of shooting stars. Originating from the debris trail left by Comet Swift-Tuttle, the Perseids are active for several weeks but peak around mid-August. During this time, observers under dark skies may see dozens of meteors per hour, sometimes more during particularly active bursts. The Perseids are known for their bright, fast streaks, many leaving glowing trails that linger for moments after the meteor has vanished. They appear to radiate from the constellation Perseus, which gives them their name. For centuries, people have watched the Perseids, weaving them into folklore and marking them as a highlight of summer nights. Today, they remain a favourite for stargazers around the world, combining predictability with beauty. Each meteor is a tiny fragment of an ancient comet, burning brightly as it falls through our atmosphere. Fact 49. Ancient records describe brilliant showers streaking across the sky. Ancient Chinese, Korean, and European texts describe sudden bursts of falling stars, sometimes numbering in the hundreds or even thousands in a single night. These records often carried symbolic weight and were interpreted as omens or signs from the heavens, filling the entire sky with blazing streaks and sparking both awe and fear. Witnesses thought the world might be ending. For modern astronomers, these historical accounts are more than just curiosities. They help track the orbits of comets and understand how debris trails spread and shift over centuries. By comparing past records with current observations, scientists can piece together the evolution of meteor streams. What was once seen as mysterious fire in the sky is now recognized as a predictable cosmic event, though the wonder it inspires remains just as strong today. Fact 50. The Geminids are unusual. Born from an asteroid rather than a comet. Most meteor showers are gifts from comets, fragile, icy wanderers that leave behind long trails of dust as they travel through the solar system. But the Geminids, one of the brightest and most intense showers of the year, come from something different. Their parent body is an asteroid, a rocky, compact object that behaves more like a burned-out comet than a true asteroid. As it approaches the Sun, this strange object sheds dusty debris that Earth later crosses each December. When those grains slam into our atmosphere at tens of thousands of miles per hour, they flare brilliantly as Geminid meteors. Unlike many other showers, the Geminids are famous for their intensity and their variety of colours, flashing white, yellow, and even green. At their peak, hundreds of meteors can streak across the heavens in a single night. That they come from an object neither fully comet nor asteroid makes them unique, a cosmic mystery that reminds us not everything fits neatly into categories. Fact 51. Venus shines so brightly that it can create shadows on Earth during dark nights. When you look toward the western horizon just after sunset, you might notice one object blazing more brilliantly than anything else around it. This is Venus, our neighbouring planet. Sometimes called the evening star or morning star, depending on when it appears. Venus reflects sunlight so powerfully because thick clouds cover its entire surface, bouncing light back into space like a giant mirror floating in the darkness. On really clear nights when Venus reaches its maximum brightness and the moon has not yet risen, this planet actually becomes bright enough to cast faint shadows on the ground below. People throughout history have marvelled at Venus, giving it names connected to beauty and love. The Romans named it after their idol of love because of its stunning appearance. Even today, Venus remains one of the easiest objects to spot in the sky, requiring no telescope or special equipment, just a clear view and a moment to look upward. Fact 52. Mars glows with a reddish tint that ancient people associated with war and blood. Another planet visible without any tools is Mars, which appears as a bright reddish point moving slowly against the background of distant stars. The red colour comes from iron oxide, which is basically rust, covering the surface of this dry, dusty world. Ancient civilizations noticed this blood-like colour and connected Mars with conflict, battle, and aggression. The Romans named it after their idol of war, continuing a tradition that began with earlier cultures. Unlike Venus, which maintains steady brightness, Mars changes dramatically depending on where it sits in its orbit relative to Earth. Sometimes it blazes brightly, becoming one of the most prominent objects in the night sky. Every 2 years or so, Earth and Mars come particularly close together, creating what astronomers call opposition, when Mars appears largest and brightest from our perspective. During these moments, even small telescopes can reveal details on its surface, including polar ice caps and dark regions that shift with seasonal changes. Fact 53. Jupiter appears as a steady, cream-coloured beacon that never twinkles like stars do. The largest planet in our solar system is also one of the easiest to identify in the night sky. Jupiter appears as a brilliantly bright, cream or yellowish point that maintains a steady glow without the twinkling effect that stars display. This stability happens because planets are close enough that they appear as tiny disks rather than single points, so atmospheric disturbances affect them less dramatically. Jupiter moves slowly across the sky over months and years, passing through different constellations as it completes its 12-year journey around the Sunday. Ancient astronomers tracked its movement carefully, recognizing it as something special and different from the fixed stars. With even basic binoculars, you can see 4 tiny points of light arranged in a line near Jupiter. These are its largest moons, discovered by Galileo over 400 years ago. Watching these moons change position from night to night provides a simple but profound demonstration that not everything in the heavens circles around Earth. Fact 54. Saturn requires patience to find, but rewards observers who seek it out. Unlike Venus or Jupiter, which command attention with their brightness, Saturn appears more subtle in the night sky. It glows with a steady pale yellow light, bright enough to be obvious once you know where to look, but easy to mistake for an ordinary star if you are not paying attention. Saturn moves even more slowly than Jupiter, taking nearly 30 years to complete one full orbit around the Sunday. This means it lingers in each constellation for a considerable time, making it easier to locate once you have identified its position. The real magic of Saturn reveals itself only through a telescope. Even a small instrument transforms this pale dot into something extraordinary, showing the magnificent ring system that encircles the planet. Those rings, made of countless chunks of ice and rock, extend far into space yet remain remarkably thin. Seeing Saturn through a telescope for the first time is an experience many people never forget. A moment when the night sky suddenly becomes real and tangible rather than just a distant backdrop. Fact 55. Mercury hides close to the Sun and appears only briefly at dawn or dusk. The innermost planet of our solar system plays a game of hide-and-seek with observers on Earth. Mercury orbits so close to the Sun that it never strays far from our star in the sky, making it visible only during brief windows just before sunrise or just after sunset. Even then, you need a clear horizon and good timing to catch a glimpse of this small, swift world. Mercury appears as a bright but small point, often sitting low in the twilight glow where haze and atmospheric thickness make viewing difficult. Ancient astronomers recognized Mercury as special because of its rapid movement across the sky, appearing and disappearing on a predictable schedule. The Greeks gave it 2 different names at first, thinking the morning and evening appearances were separate objects. Eventually they realized it was one planet moving quickly through its orbit. Today, Mercury remains one of the more challenging naked-eye planets to spot, not because it is particularly faint, but because it never ventures far from the Sun's overwhelming glare. Fact 56. Uranus technically reaches naked-eye visibility, but few people ever notice it without help. At the outer edges of what human eyes can detect sits Uranus, the 7th planet from the Sunday. Under perfect conditions, away from any light pollution and with exceptional eyesight, this distant world barely reaches the threshold of visibility. It appears as an extremely faint bluish dot, so dim that it blends completely into the background of other faint stars. For thousands of years, nobody realized Uranus existed as a planet because it moved so slowly and appeared so unremarkable. Astronomers finally identified it as something unusual in the late 1700s, when telescopes became powerful enough to reveal its disk-like appearance. Even today, finding Uranus without optical aid requires detailed star charts, patience, and ideal observing conditions. Most people never see it with their eyes alone, though technically the possibility exists. Through binoculars or telescopes, Uranus transforms from invisible to merely subtle, a tiny greenish-blue disk sitting far beyond the orbit of Saturn, taking 84 years to circle the Sun just once. Fact 57. Neptune remains forever invisible to the unaided eye, but telescopes reveal its deep blue colour. Even farther out than Uranus lies Neptune, a world completely beyond the reach of human vision without technology. This distant planet shines so faintly that no amount of darkness or perfect conditions can bring it into view with eyes alone. Astronomers discovered Neptune not by seeing it first, but by calculating where it should be based on gravitational effects it had on Uranus. When they finally pointed telescopes at the predicted location, Neptune appears as a small, rich blue disk through powerful instruments, coloured by methane in its atmosphere that absorbs red light and reflects blue wavelengths back into space. This planet takes 164 years to complete a single orbit, meaning it has not yet finished one full journey around the Sun since humans first discovered it. Neptune reminds us that the universe contains countless wonders completely hidden from our direct senses, waiting to be found through patience, mathematics, and the tools we build to extend our perception. Fact 58. The Moon shows the same face toward Earth because of tidal locking. Our closest neighbour in space presents us with a curious mystery that ancient people could not explain. No matter when you look at the Moon, you always see essentially the same features. The dark patches form the same patterns, the bright craters occupy the same positions, and nothing on the far side ever rotates into view. This happens because of something called tidal locking, a gravitational effect that has synchronized the Moon's rotation with its orbit around Earth. The Moon does spin, but it completes exactly one rotation in the same time it takes to orbit our planet once. This perfect matching means one hemisphere always faces toward us, while the other remains permanently hidden. Ancient cultures created stories about the patterns they saw on the visible side, imagining faces, animals, or symbolic shapes in the arrangement of light and dark regions. Nobody knew what existed on the far side until spacecraft finally travelled around the Moon and photographed it in the 20th century, revealing a surface just as cratered and ancient, but notably different in appearance. Fact 59. Lunar craters preserve billions of years of cosmic impacts frozen in time. The Moon's surface tells a violent story written in stone and dust. Every crater, from tiny pits to massive basins hundreds of miles across, marks where an object from space crashed into the lunar surface. Unlike Earth, where wind, water, and geological activity constantly erase evidence of impacts, the Moon has no atmosphere and little internal heat. Craters that formed billions of years ago remain almost perfectly preserved, creating a historical record of bombardment that spans the entire age of the solar system. The largest craters, visible even without binoculars, are called maria or seas, though they contain no water. Ancient astronomers thought these dark, smooth regions might be actual oceans, giving them names like the Sea of Tranquility or the Ocean of Storms. Actually, these are vast plains of solidified lava that filled enormous impact basins long ago. Walking on the Moon would mean walking on surfaces that have barely changed in eons, where every footprint and disturbance remains visible indefinitely because nothing exists to disturb it. Fact 60. The Moon creates tides on Earth by pulling water with its gravity. Twice each day, the oceans rise and fall in a rhythm that has shaped coastlines and marine life for as long as water has existed on our planet. This movement happens because the Moon's gravity reaches across space and pulls on Earth, including the water covering most of its surface. The side of Earth facing the Moon experiences the strongest pull, causing water to bulge outward toward it. Interestingly, water on the opposite side also bulges outward because that region experiences slightly less gravitational pull than the solid Earth between it and the Moon. As our planet rotates beneath these two bulges, any given location experiences two high tides and two low tides approximately every 24 hours. The Sun also contributes to tides, and when the Sun and Moon align during new or full moons, their combined gravitational effects create especially strong spring tides. When they work at right angles during quarter moons, weaker neap tides result. These cycles have governed ocean life, navigation, and coastal cultures throughout human history, all driven by the gentle but persistent tug of our companion in the sky. Fact 61. Lunar eclipses turn the moon copper red rather than making it disappear completely. When Earth passes directly between the sun and moon, you might expect our planet's shadow to completely hide the moon from view, plunging it into total darkness. Instead, something beautiful happens. The moon takes on a deep orange, red, or copper color, glowing softly against the blackness. This happens because Earth's atmosphere bends some sunlight around the edges of our planet, filtering it in the process. The atmosphere scatters away blue light, the same process that makes our sky appear blue during the day and sunsets look red. Only the red and orange wavelengths make it through, curving around Earth and illuminating the moon with a strange, dim light. Every lunar eclipse looks slightly different depending on conditions in Earth's atmosphere. Volcanic eruptions, dust storms, or other particles in the air can make the moon appear darker and redder. Ancient people feared these events, seeing them as omens or supernatural occurrences. Today, we understand the physics, but watching the moon transform from bright silver to dark crimson remains one of the most captivating events in the night sky. Fact 62. Total solar eclipses reveal the sun's corona in a display of ethereal beauty. Among all celestial events, total solar eclipses stand apart as perhaps the most dramatic and awe-inspiring. For just a few minutes, the moon passes directly between Earth and the sun, blocking the blazing disk completely. Around the black circle of the moon, the sun's corona becomes visible. A pearly white halo of superheated gas extending millions of miles into space. This outer atmosphere of the sun remains invisible during normal conditions because the sun's bright surface overwhelms it completely. Only during totality can we see these delicate streamers and loops without special equipment. Ancient civilizations recorded eclipses with fear and reverence, sometimes seeing them as signs of divine anger or cosmic struggle. Modern astronomers travel thousands of miles to position themselves in the narrow path where totality occurs, because the view from even a few miles outside that path shows only a partial eclipse, missing the corona entirely. Those few minutes of totality create memories that last lifetimes, a reminder of how small we are and how precisely the cosmic machinery operates. Fact 63. The precise alignment needed for total solar eclipses happens by remarkable coincidence. The sun measures about 400 times wider than the moon, but it also sits roughly 400 times farther away from Earth. This means both objects appear almost exactly the same size in our sky, a matching so precise that the moon can just barely cover the sun's disk during a total eclipse. This alignment is temporary on cosmic timescales. The moon slowly moves away from Earth at about 1.5 inches each year, so in the distant future, it will appear too small to create total eclipses. In the distant past, it appeared larger, creating longer periods of totality. Right now, in this brief window of planetary history, humans exist during the era when total solar eclipses occur with spectacular precision. Nothing about physics requires this matching, it simply happened this way by chance. We live in a time when the view from Earth includes one of the universe's most beautiful natural phenomena, available only because of a lucky coincidence of size and distance. Fact 64. Auroras dance across polar skies when solar particles interact with Earth's atmosphere. Green, pink, red, and purple waves ripple and dance overhead, moving like living things across the darkness. These auroras, called the Northern Lights or Aurora Borealis in the north and Southern Lights or Aurora Australis in the south, occur when charged particles from the sun collide with gases in Earth's upper atmosphere. The sun constantly releases a stream of particles called the solar wind, which flows outward through the solar system. When these particles encounter Earth's magnetic field, they get funneled toward the poles, where they slam into oxygen and nitrogen molecules high above the surface. These collisions energize the atmospheric gases, causing them to glow in various colors depending on altitude and which gas is involved. Oxygen produces green and red light, while nitrogen creates blue and purple hues. Indigenous peoples living in aurora zones have developed rich mythologies around these lights, seeing them as spirits, ancestors, or supernatural forces. Scientists now understand the physical processes, but the beauty and majesty remain undiminished by knowledge. Fact 65. Powerful solar storms can push auroras far from their usual polar homes. Typically, you need to travel to Alaska, northern Canada, Scandinavia, or similar high-latitude regions to witness auroras regularly. However, the Sun does not maintain constant output. Sometimes it releases particularly powerful bursts of energy called coronal mass ejections, which send enormous clouds of charged particles racing through space. When these powerful storms reach Earth, they can overwhelm the usual confinement of auroras to polar regions. During these events, people living in normally aurora-free zones suddenly see these lights dancing in their own skies. Historical records describe auroras visible as far south as the Caribbean or northern Africa during especially intense solar storms. In 1859, a storm so powerful that telegraph systems sparked and failed brought auroras to tropical latitudes, creating global wonder and confusion. The Sun follows an 11-year cycle of activity, with more frequent and powerful storms occurring near the peak of each cycle. During these active periods, auroras appear more often and spread farther from the poles, giving more people the chance to witness one of nature's most spectacular light shows. Fact 66. Ancient stone monuments align with specific sunrise and sunset positions throughout the year. Thousands of years before written history, people carefully observed the sky and built structures that captured important moments in the seasonal cycle. Stonehenge in England, Newgrange in Ireland, and countless other monuments scattered across the world contain alignments that mark specific astronomical events. At Stonehenge, the rising sun on the summer solstice shines directly through an arrangement of massive stones, illuminating a central altar. At Newgrange, sunlight penetrates a narrow passage only during the winter solstice, flooding an inner chamber that remains dark the rest of the year. These alignments were not accidental. They required careful observation over many years and precise construction with tools we would consider primitive. The monuments served multiple purposes, functioning as calendars, ceremonial sites, and demonstrations of astronomical knowledge. They show that ancient peoples understood the sky deeply, recognizing patterns and cycles that governed agriculture, seasons, and cultural life. Standing at one of these sites during an alignment event creates a powerful connection across millennia, reminding us that humans have always looked upward, seeking meaning and order in the movement of celestial objects. Fact 67. The zodiac constellations mark the path the Sun appears to follow across the sky. As Earth orbits the Sun, our perspective constantly changes, making the Sun appear to move against the background of distant stars. Over the course of 1 year, the Sun traces out a path through the sky called the ecliptic, passing through a series of constellations that ancient astronomers grouped together and called the zodiac. These 12 constellations, including familiar names like Leo, Scorpio, and Gemini, occupied special importance in ancient cultures because they marked where the Sun, Moon, and planets travelled. Astrology, the belief that celestial positions influence human affairs, developed around these patterns thousands of years ago. While modern science finds no evidence for astrological effects, the constellations themselves remain useful markers. Astronomers still refer to the ecliptic and zodiac constellations when describing planetary positions. Over extremely long periods, the precession of Earth's axis causes the zodiac to shift relative to the calendar, meaning the Sun no longer occupies the traditional astrological positions at the times ancient astrologers determined. Nevertheless, these star patterns continue to hold cultural significance and provide a framework that connects us to ancient skywatchers who first recognized these patterns. Fact 68. Planets never stray far from the ecliptic as they wander through the constellations. If you track the positions of the visible planets over weeks and months, you will notice they always remain near the same band of sky where the Sun and Moon travel. This happens because all the major planets orbit the Sun in roughly the same flat plane, like marbles rolling around on a tabletop. From our perspective on Earth, which also orbits in that same plane, we see the planets moving along the ecliptic, passing through the zodiac constellations just like the Sun does. Ancient astronomers recognized this pattern and distinguished planets from stars partly by their restricted movement. While stars maintain fixed patterns, Planets wander, sometimes moving forward, sometimes appearing to reverse direction in a motion called retrograde. This retrograde motion confused observers for centuries until they realized it resulted from Earth overtaking slower outer planets or being overtaken by faster inner planets. Today, finding planets becomes easier when you know they will always appear somewhere along the ecliptic. Look for bright objects that do not twinkle, positioned along the same path the sun follows during the day, and you have likely found one of our neighbouring worlds. Fact 69. Comets have inspired wonder and fear throughout recorded history. These icy wanderers occasionally sweep close to the sun, developing spectacular tails that can stretch across enormous portions of the sky. Ancient people saw comets as mysterious visitors, often interpreting their appearance as omens of disaster, death, or profound change. Chinese, Babylonian, and European records contain detailed descriptions of notable comets, often linked to the deaths of rulers or major historical events. The sudden appearance of something new and dramatic in the usually predictable sky felt unsettling, as if the heavens themselves were sending warnings. Today we understand comets as frozen chunks of ice, rock, and dust that spend most of their time in the cold outer solar system. When their long elliptical orbits bring them close to the sun, solar heat vaporizes some of the ice, releasing gas and dust that streams away in glowing tails. The tails always point away from the sun, blown by solar wind, rather than trailing behind like exhaust. Some comets return regularly, while others appear only once and then vanish back into the darkness for thousands of years or forever. Fact 70. Halley's Comet returns every 76 years in one of astronomy's most reliable shows. Among all the comets that visit the inner solar system, none has been more thoroughly documented or more eagerly anticipated than Halley's Comet. This icy traveller completes one orbit every 75 to 76 years, returning with clockwork regularity throughout recorded history. Ancient records from China, Babylon, and Europe describe appearances that we can now connect to specific returns of this same comet. English astronomer Edmund Halley recognized in the early 1700s that several historical comet sightings actually represented the same object returning periodically, and he correctly predicted its return in 1759. Since then, the comet has borne his name. Halley's Comet last visited the inner solar system in 1986, putting on a somewhat disappointing show because Earth's position was not ideal for viewing. It will return again in 2061, giving people alive today one chance, or perhaps two if they are very young or very lucky, to witness this legendary visitor. Each appearance connects observers across generations, creating a thread of continuity that spans thousands of years and countless human lifetimes. Fact 71. Planets beyond Neptune exist but remain invisible without powerful telescopes. At the edge of our solar system, far beyond the orbit of Neptune, a population of small icy worlds drifts through the darkness. These distant objects are so far away and reflect so little sunlight that even the best ground-based telescopes struggle to detect them. For many years, astronomers suspected additional worlds existed beyond Neptune because of subtle gravitational effects they seem to produce. In 1930, astronomers discovered Pluto, which was considered the ninth planet for decades. Later, as technology improved, scientists found many other objects in the same distant region, some nearly as large as Pluto itself. This led to a reclassification, with Pluto being designated as one member of a larger population of dwarf planets and trans-Neptunian objects. These distant worlds have exotic orbits, extreme tilts, and compositions dominated by frozen methane, nitrogen, and water. Some take hundreds or even thousands of years to complete a single orbit around the Sunday. They represent the raw leftovers from the solar system's formation, preserved in a deep freeze for billions of years. Exploring this region remains one of the frontiers of planetary science, with each new discovery revealing surprises. Fact 72. Spacecraft have visited every major planet and transformed our understanding completely. For thousands of years, humans could only observe planets as points of light moving slowly across the sky. Even through telescopes, they remained distant and mysterious. Everything changed when we began sending robotic explorers into space. Starting in the 1960s and continuing through today, spacecraft have visited every major planet, many moons, and even distant dwarf planets and asteroids. These missions transformed fuzzy telescopic views into detailed landscapes, revealing worlds of stunning diversity and complexity. We discovered that Jupiter's Great Red Spot is a storm larger than Earth that has raged for centuries. We found erupting volcanoes on Jupiter's moon, Io, and subsurface oceans beneath the ice of Europa. We mapped the clouds of Venus and the canyons of Mars. We saw Saturn's rings up close and flew past the strange hexagonal storm at its north pole. Neptune's winds proved to be the fastest in the solar system. Each discovery expanded our understanding and raised new questions. These missions represent some of humanity's greatest achievements, extending our senses across billions of miles and bringing back knowledge that would have seemed like fantasy just a few generations ago. Fact 73. Light takes over 8 minutes to travel from the Sun to Earth. The speed of light is staggeringly fast, crossing nearly 186,000 miles every second. Yet even at this incredible velocity, light needs time to cover the enormous distances in space. Sunlight, leaving the surface of our star, must journey through the emptiness for more than 8 minutes before it finally reaches Earth and warms our skin or illuminates our day. This means that when you look at the Sun, you are not seeing it as it exists in this exact moment. You are seeing it as it appeared slightly more than 8 minutes ago. If the Sun suddenly vanished, we would continue to see it shining for those 8 minutes until the final light reached us. Of course, this will never happen, but the thought experiment reveals something profound about the nature of light and distance. Everything we observe in the universe comes from the past, with the delay growing longer as we look farther away. The night sky is not a snapshot of the present moment, but a collection of images from different moments in history, all arriving together at our eyes. Fact 74. Light from the farthest galaxies has travelled for billions of years to reach us. The most distant objects we can observe through powerful telescopes are galaxies sitting at the very edge of the observable universe. Light from these galaxies began its journey billions of years ago, when the universe itself was young and very different from today. By the time that light finally reaches Earth and enters our telescopes, those distant galaxies have moved even farther away and changed dramatically. We are not seeing them as they currently exist, but as they appeared in the ancient past. Some of the galaxies whose light we detect today may no longer exist in their original form, having merged with neighbours or transformed over cosmic time. This creates a strange situation where astronomers can look backward through time simply by looking outward into space. The farther away something sits, the older the image we receive. This allows scientists to study the history of the universe by comparing nearby recent galaxies with distant ancient ones. The night sky becomes a living museum, displaying billions of years of cosmic evolution all at once, layers of history stacked on top of each other in every direction we choose to look. Fact 75. The observable universe has boundaries determined by the speed of light and cosmic expansion. You might imagine the universe extends infinitely in all directions, containing an endless number of galaxies and stars. However, there exists a practical limit to what we can observe. Because the universe has a finite age, approximately 13.8 billion years, light has had only that much time to travel toward us. Anything farther away than light could travel in that time remains invisible, not because it does not exist, but because its light has not reached us yet. Additionally, the universe itself is expanding, which means distant objects are moving away from us. Beyond a certain distance, objects recede so quickly that their light can never catch up to us no matter how long we wait. These two factors combine to create a boundary called the cosmic horizon, marking the edge of the observable universe. Beyond this horizon, galaxies and stars certainly exist, but we can never see them or receive information from them. The observable universe forms a sphere centered on Earth, not because we occupy a special position, but simply because every observer anywhere would see their own cosmic horizon at roughly the same distance, centered on their own location. Fact 76. Space-time itself curves around massive objects like valleys around heavy stones. Instead, Space and time together form a flexible fabric that bends and curves when massive objects sit within it. Imagine placing a bowling ball on a stretched rubber sheet. The ball creates a depression, and smaller objects rolling nearby will curve toward it, following the slope created by the weight. Gravity works similarly in our universe. The Sun creates a deep curve in space-time, and planets follow the curved paths around it, not because an invisible force pulls them, but because they are moving through curved geometry. This concept, developed by Albert Einstein, completely changed how scientists understand gravity. Light itself follows these curves, bending around massive objects in a phenomenon called gravitational lensing. Astronomers use this effect to study distant galaxies, watching their light curve around closer clusters of galaxies that act like cosmic magnifying glasses. What appears as a mysterious pulling force is actually just objects moving along the shortest path through curved spacetime. Fact 77. Space stations orbit Earth by falling continuously without ever hitting the ground. Astronauts aboard the International Space Station float weightlessly through their modules, seemingly defying gravity. However, they are not actually beyond the reach of Earth's gravitational pull. At the altitude where the station orbits, gravity remains nearly as strong as on the surface. The station and everyone inside it are constantly falling toward Earth, but they are also moving sideways so fast that they keep missing it. This creates what scientists call a stable orbit. Think of throwing a ball horizontally. It curves downward as gravity pulls it, eventually hitting the ground. If you could throw it fast enough, by the time it fell toward Earth, the planet's surface would have curved away beneath it. The ball would keep falling around Earth without ever landing. This is exactly what orbiting objects do. They fall continuously, creating the sensation of weightlessness, because everything inside, including the astronauts, falls together at the same rate. There is no floor pushing up against them, no support holding them, just perpetual falling that never ends. Fact 78. Astronauts see 16 sunrises and sunsets every single day while orbiting overhead. Life aboard a space station follows a rhythm completely unlike anything experienced on Earth. The International Space Station circles our planet approximately every 90 minutes, completing 16 full orbits during each 24-hour period. This means that astronauts witness sunrise and sunset 16 times each day as they race around Earth. The transition happens quickly. Darkness turns to brilliant light as the sun crests over the horizon, flooding the station with golden rays. Then, just 45 minutes later, the sun plunges below the opposite horizon, bringing night again. These rapid cycles make maintaining a normal sleep schedule challenging. Mission Control helps by establishing an artificial day and night schedule, dimming lights and curtaining windows to create rest periods. Otherwise, the constant cycling between light and darkness would confuse the body's natural rhythms completely. Astronauts describe the beauty of these rapid sunsets and sunrises as one of the most memorable aspects of spaceflight, watching Earth's atmosphere glow in layers of orange, red, and blue as the sun angles through it during each transition. Fact 79. Stars form inside, collapsing clouds when gravity overcomes gas pressure. New stars do not simply appear out of nothing. They are born inside enormous clouds of gas and dust called molecular clouds, regions so vast they can span hundreds of light years. These clouds contain mostly hydrogen, along with traces of other elements and tiny particles of dust. For millions of years, they might drift through space unchanged, held in balance between the outward pressure of their gas and the inward pull of their own gravity. Sometimes, an external event, perhaps a nearby supernova or a collision with another cloud, disturbs this balance. Gravity begins winning. Parts of the cloud start collapsing inward, growing denser and hotter as material piles up. Hydrogen atoms begin fusing together, releasing enormous amounts of energy. At this moment, a star ignites, beginning a lifespan that might last billions of years. The leftover material around the newborn star might form planets, moons, asteroids, and comets, creating an entire solar system from the remains of the stellar birth process. Fact 80. Young stars often appear in clusters, where dozens form together from shared material. Instead, hundreds or even thousands of young stars emerge together in clusters, all born from the same collapsing cloud within a relatively brief period. These stellar nurseries glow brightly with the combined light of their newborn inhabitants, often surrounded by colourful nebulae still glowing from the energy these young stars pump into their surroundings. The Pleiades cluster represents one such family, its members all formed around the same time and still travelling through space together. Over millions of years, these clusters gradually spread apart as the individual stars drift along their own paths through the galaxy. Some clusters stay together for billions of years, like the ancient globular clusters, while others disperse relatively quickly. Even our own Sun likely formed within such a cluster, though its siblings have long since scattered across the galaxy. Somewhere out there, other stars share the Sun's birth cloud, distant relatives we may never identify because they have drifted too far apart to recognize their connection. Fact 81. Stellar winds blow constantly from stars carrying away material into space. Just as Earth experiences wind created by moving air, stars generate their own winds made of charged particles streaming outward into space. Our Sun produces such a wind, a constant flow of electrons, protons, and other particles racing away at speeds of hundreds of miles per second. This solar wind fills the entire solar system, creating a bubble of influence that extends far beyond the orbits of the planets. When this wind encounters Earth's magnetic field, it creates the auroras we sometimes see dancing in polar skies. Other stars produce winds too, some far more powerful than our Sun's gentle breeze. Massive young stars blast away material so violently they can actually limit their own growth by blowing away the gas that would otherwise fall onto them. Old dying stars produce powerful winds as they shed their outer layers into space. These stellar winds, combined with material ejected by supernovas, constantly recycle elements throughout galaxies, distributing the building blocks for new stars and planets across vast regions of space. Fact 82. Different wavelengths of radiation reveal hidden features invisible to human eyes. When we look at the night sky with our eyes, we see only visible light, a narrow slice of the full electromagnetic spectrum. But celestial objects emit radiation across a vast range of wavelengths, from radio waves to gamma rays. Each wavelength reveals different information. Radio telescopes detect emissions from cold gas clouds and pulsars. Infrared instruments peer through dust clouds to see forming stars hidden from visible light. Ultraviolet observations show the hottest stars and energetic processes. X-ray telescopes find neutron stars, black holes, and the superheated gas in galaxy clusters. Gamma-ray detectors catch the most violent explosions in the cosmos. By observing the same object at multiple wavelengths, astronomers build a complete picture of what is happening. A galaxy that looks calm in visible light might glow brilliantly in X-rays, revealing a supermassive black hole actively consuming matter at its center. A star-forming nebula might hide behind dust in visible images, but shine clearly in infrared. The universe looks completely different depending on which wavelength you choose to observe, like having different colored filters that each reveal a hidden layer of reality. Fact 83. Radio telescopes have detected signals from the earliest moments after the Big Bang. Shortly after the universe began, it existed as an incredibly hot, dense state filled with energy and matter. As it expanded and cooled, atoms eventually formed, allowing light to travel freely for the first time. This ancient light, stretched by billions of years of cosmic expansion, still fills the universe today as microwave radiation. Scientists call it the cosmic microwave background, and it represents the oldest light we can detect, a baby picture of the universe taken when it was only 380,000 years old. Radio telescopes tuned to microwave frequencies can detect this faint glow coming from every direction in space. By carefully mapping tiny variations in its temperature, astronomers have learned about the early universe's structure, composition, and behavior. These measurements have confirmed many predictions about how the cosmos formed and evolved. To detect this signal requires extraordinary precision, separating it from countless other sources of radio noise. The cosmic microwave background connects us directly to the beginning of time itself. Fact 84. Dark matter shapes galaxies yet remains completely invisible to all telescopes. When astronomers calculate how much mass exists in galaxies based on visible stars, gas, and dust, the numbers do not add up. Galaxies rotate in ways that should tear them apart. If only the visible matter existed. Something else must be present, providing additional gravity to hold everything together. Scientists call this mysterious substance dark matter, and it appears to make up roughly 85% of all matter in the universe. Despite its abundance, dark matter does not emit, absorb, or reflect light at any wavelength. It reveals itself only through gravitational effects on visible matter. Galaxies sit embedded in huge halos of dark matter. Galaxy clusters contain so much dark matter that their gravity bends light from more distant objects behind them. Without dark matter, galaxies could not have formed in the first place. Yet despite decades of searching, nobody knows what dark matter actually consists of. It might be exotic particles that barely interact with ordinary matter, drifting through space and even through planets without touching anything. Understanding dark matter remains one of the biggest mysteries in modern science. Fact 85. Dark energy pushes the universe apart, causing expansion to accelerate over time. For most of the 20th century, astronomers assumed the universe's expansion was gradually slowing down, decelerated by the gravitational attraction of all the matter it contains. Then, in the late 1990s, observations of distant supernovas revealed something shocking. The expansion is not slowing down, but speeding up. Some unknown force appears to be pushing space itself apart, overcoming gravity on the largest scales. Scientists named this mysterious influence dark energy, though the name reveals our ignorance rather than our understanding. Dark energy seems to make up roughly 70% of all the energy in the universe, yet nobody knows what it is or how it works. It behaves unlike any form of matter or energy we have encountered. As the universe continues expanding, dark energy's influence grows stronger. Eventually it may overcome even the gravity holding galaxies together. Understanding dark energy stands as one of the most profound challenges facing physics. The fate of the universe, whether it expands forever or eventually collapses, depends entirely on the nature and behavior of this invisible force. Fact 86. Ancient supernovas created the calcium in your bones and iron in your blood. Every atom in your body, except hydrogen, was forged inside a star. The carbon in your cells, the oxygen you breathe, the calcium in your skeleton, the iron in your blood, all of these elements formed through nuclear fusion in stellar cores. Lightweight elements like carbon and oxygen are created in normal stars throughout their lives. Heavier elements like iron require the intense pressures and temperatures found in massive stars. The very heaviest elements, including gold, silver, and uranium, form only during supernova explosions or collisions between neutron stars. When these catastrophic events occur, they scatter these elements across space in expanding clouds of debris. Later, new stars and planets form from this enriched material, incorporating the ashes of previous generations. The Sun and everything in our solar system, including Earth and all life on it, condensed from such a cloud roughly 4.6 billion years ago. This means you are literally made of stardust, atoms that once resided in stars that lived and died before the Sun even existed. Your body carries within it the history of stellar evolution written in chemical elements. Fact 87. Neutron stars pack more mass than the Sun into spheres smaller than cities. When a massive star collapses during a supernova, its core can compress into an object so dense that a teaspoon of its material would weigh as much as all of humanity combined. These neutron stars pack roughly 1.4 to 2 times the Sun's mass into spheres only about 12 to 15 miles across. At such densities, atoms cannot exist in their normal form. Protons and electrons merge to form neutrons, creating matter unlike anything found anywhere else in the universe. The surface gravity on a neutron star is billions of times stronger than Earth's. If you could somehow stand on one, you would be instantly crushed flatter than a sheet of paper. The magnetic fields around many neutron stars exceed anything we can create in laboratories. strong enough to distort the very structure of empty space. Some neutron stars spin hundreds of times per second, rotating faster than a kitchen blender. These exotic objects push the laws of physics to their extremes, creating conditions we can barely imagine and certainly cannot reproduce anywhere else. Fact 88. White dwarfs glow from leftover heat slowly cooling over billions of years. When stars like our Sun exhaust their nuclear fuel, they cannot maintain the internal pressure needed to support their outer layers against gravity. These layers drift away into space, leaving behind only the hot, dense core. Instead, it shines from residual heat left over from its active lifetime, slowly radiating that energy away over billions of years. White dwarfs are remarkably dense, packing a mass similar to the Sun's into a volume about the size of Earth. Eventually, given enough time, white dwarfs will cool completely and become black dwarfs, dark cinders drifting through space. However, the universe is not old enough yet for any white dwarf to have completely cooled. Even the oldest ones still emit faint light. Our Sun will become a white dwarf in approximately 5 billion years, after exhausting its hydrogen fuel and swelling into a red giant that engulfs the inner planets. What remains will gradually fade, a monument to billions of years of nuclear burning. Fact 89. Some binary systems contain one living star and one stellar corpse orbiting together. Not all stars die alone. In binary systems, where one star is more massive than its companion, it will exhaust its fuel first, collapsing into a white dwarf, neutron star, or black hole, while its partner continues burning normally. This creates an unusual pairing, one living star and one dead remnant locked in gravitational embrace. Sometimes the remnant can pull material from its companion, drawing gas away in streams that spiral inward. When this stolen material accumulates and heats up, it can trigger violent outbursts. Neutron stars can emit jets of X-rays as stolen material crashes onto their surfaces. Black holes glow brightly in X-rays as they devour their companions piece by piece. These systems can eventually become unstable, with the theft of material sometimes causing catastrophic explosions that destroy both objects. Observing these binary systems helps astronomers understand stellar death and the bizarre physics that governs the strongest gravitational fields in the universe. Fact 90. Type 1. Supernovas occur when white dwarfs accumulate too much stolen material. Among the various types of stellar explosions, one variety stands out for its unusual consistency. Type 1 supernovas all reach approximately the same peak brightness, making them useful as distance markers across cosmic scales. These explosions happen in binary systems where a white dwarf steadily pulls material from a companion star. It approaches a critical threshold. When it exceeds roughly 1.4 times the Sun's mass, something catastrophic happens. The internal pressure from the added weight triggers runaway carbon fusion throughout the entire white dwarf simultaneously. The star does not just explode, it completely obliterates itself in a thermonuclear detonation that outshines entire galaxies for weeks. Because these explosions always happen at essentially the same mass threshold, they always produce roughly the same amount of light. Astronomers use this predictability to measure distances to faraway galaxies, comparing how bright the supernova appears with how bright it actually is, revealing how far away the explosion occurred. Fact 91. Gravitational waves ripple through spacetime when massive objects collide or spiral together. Einstein's theory predicted that accelerating massive objects should create ripples in spacetime itself, like waves spreading across a pond when you drop a stone. For a century, these gravitational waves remained purely theoretical, too faint for existing technology to detect. Then, in 2015, scientists finally recorded them for the first time, using incredibly sensitive instruments called interferometers. The signal came from two black holes spiraling together and merging, an event so violent it briefly released more energy than all the stars in the observable universe combined. Since then, researchers have detected dozens of these events, including collisions between neutron stars and mergers involving black holes of various sizes. Gravitational waves carry information completely different from light, revealing aspects of cosmic events that electromagnetic radiation cannot show. They travel through the universe unimpeded, not absorbed or scattered by intervening matter. This opens a new way to explore the cosmos, allowing scientists to witness events that would otherwise remain invisible. Gravitational wave astronomy represents a revolution, giving us a new sense for experiencing the universe. Fact 92. Massive stars live fast and die young compared to smaller, cooler companions. A star's lifespan depends critically on how much mass it contains. Massive stars burn brilliantly hot, fusing their nuclear fuel at prodigious rates. A star 10 times the Sun's mass might exhaust its fuel in only 10 million years, less than 1% of the Sun's expected lifetime. These giants shine thousands of times brighter than average stars, dominating their surroundings with intense radiation and powerful winds. When they die, they do so spectacularly in supernova explosions. Small stars, by contrast, live miserly existences. Red dwarfs, the most common type of star in the galaxy, burn so slowly and efficiently that they can maintain fusion for trillions of years, far longer than the current age of the universe. This means every red dwarf that ever formed still exists today. The smallest red dwarfs will outlast everything else in the cosmos, still glowing faintly long after massive stars have all exploded and white dwarfs have faded to darkness. Size determines not just brightness but longevity, creating a strange inverse relationship where the brightest stars are the most fleeting. Fact 93. Planets exist around other stars in astonishing variety and abundance. For centuries, scientists could only speculate about whether other stars hosted planets like those orbiting our Sun. The first confirmed detection of a planet around a Sun-like star came in 1995, opening a floodgate of discovery. Today, thousands of exoplanets have been catalogued, with new ones identified regularly. These distant worlds display stunning diversity. Some orbit scorchingly close to their stars, completing years in just days. Others drift through frozen outer regions. Hot Jupiters, massive gas giants hugging their stars, challenge theories about how solar systems form. Super-Earths, rocky planets larger than ours but smaller than Neptune, represent a type completely absent from our own system. Some planets orbit binary stars, experiencing complex days with two suns. Others drift alone through interstellar space, ejected from their birth systems. Nearly every star in the galaxy likely hosts planets, meaning hundreds of billions exist in the Milky Way alone. This abundance has transformed our understanding of planetary formation and sparked serious scientific investigation into the possibility of life elsewhere in the cosmos. Fact 94. Some exoplanets orbit in zones where liquid water could potentially exist on surfaces. Among the thousands of known exoplanets, a small fraction orbit at distances where temperatures might allow water to remain liquid on their surfaces, neither boiling away nor freezing solid. Scientists call this region the habitable zone, or sometimes the Goldilocks zone, after the fairy tale about conditions being just right. Whether a planet actually has liquid water depends on many factors beyond distance, including atmospheric composition, pressure, and the presence of greenhouse gases. Venus sits within the Sun's habitable zone but remains hellishly hot because of its thick carbon dioxide atmosphere. Mars technically orbits at the outer edge but lost most of its atmosphere long ago, leaving its surface cold and dry. Finding planets in habitable zones around other stars focuses the search for potentially life-bearing worlds. Telescopes study the atmospheres of these candidates, looking for chemical signatures that might indicate biological processes. While distance alone does not guarantee habitability, it represents a starting point for identifying worlds that might, just possibly, host life. Fact 95. The search for extraterrestrial life focuses both on radio signals and chemical biosignatures. Humans have searched for signs of intelligent life beyond Earth for decades, primarily by listening for radio transmissions that might leak from alien civilizations or be deliberately sent as messages. Large radio telescopes scan the skies continuously, sorting through cosmic noise for patterns that suggest artificial origin. So far, this search has found nothing conclusive, though the universe is vast and we have examined only a tiny fraction of possible targets. More recently, scientists have begun looking for indirect evidence of life by studying exoplanet atmospheres. Certain combinations of gases, particularly oxygen alongside methane, might indicate biological activity because these chemicals react with each other and should not coexist unless something continuously replenishes them. Future telescopes will analyze starlight filtered through exoplanet atmospheres, searching for these chemical fingerprints. Finding even simple microbial life elsewhere would represent one of the most profound discoveries in human history, answering whether Earth is unique or whether life is common throughout the cosmos. The search continues, driven by curiosity and the fundamental question of whether we are alone. Fact 96. The Voyager spacecraft carry golden records with sounds and images from Earth. In 1977, NASA launched two spacecraft called Voyager 1 and Voyager 2 on missions to explore the outer planets. After completing their primary objectives, these robotic explorers continued traveling outward, eventually leaving the solar system entirely and entering interstellar space. Both craft carry identical golden phonograph records, circular discs containing sounds and images selected to represent Earth's diversity. The recordings include greetings in dozens of languages, musical selections from various cultures, natural sounds like thunder and whale songs, and encoded images showing human anatomy, landscapes, and mathematical concepts. These records serve as messages in bottles cast into the cosmic ocean. The chances of any alien civilization ever finding them are vanishingly small, given the vast emptiness between stars. Yet the gesture itself holds meaning, a demonstration that humans recognize our place in a larger universe and hope to communicate across the gulf of space. The Voyagers will drift through interstellar space essentially forever, carrying their cargo of sounds and pictures as ambassadors long after humanity is gone. Fact 97. Space contains more emptiness than matter by overwhelming proportions. Despite all the stars, galaxies, planets, and other objects scattered throughout the cosmos, space itself is almost entirely empty. The distances between objects are so vast compared to their sizes that matter represents only a tiny fraction of the total volume. If you could shrink our solar system to the size of a football field, most planets would be smaller than grains of sand scattered hundreds of feet apart. The space between stars is even more extreme. If you could travel at the speed of light, you would reach the nearest star in just over 4 years, yet during that entire journey you would encounter hardly any matter at all. Between galaxies, the emptiness becomes even more profound, with only a few atoms per cubic meter drifting through the void. The universe is fundamentally a study in emptiness, with all the matter and energy clumped into tiny islands separated by unimaginable voids. This emptiness is not nothingness, however. Quantum physics suggests even the vacuum seethes with virtual particles constantly appearing and disappearing, energy fluctuating at the smallest scales. Fact 98. Looking at stars connects us directly with humans throughout history. Every person who ever lived saw essentially the same stars we observe today. Ancient Egyptians watched Sirius rise before the Nile flooded. Polynesian navigators guided their canoes by the same constellations visible from modern beaches. Medieval farmers marked planting seasons by star positions still recognized tonight. The sky provides a thread connecting all of humanity across thousands of years, while civilizations rose and fell, while languages changed and cultures transformed, the stars remained largely constant. This shared experience spans not just human history but reaches back to our earliest ancestors who first looked upward with awareness and wonder. When you gaze at the night sky, you participate in something ancient and universal. The photons entering your eyes tonight began their journeys decades, centuries, or even thousands of years ago, carrying information across time and space to reach you at this particular moment. This connection extends beyond humans to include all life on Earth. Evolution occurred beneath these same stars. Every thought, every discovery, every triumph and tragedy in the history of life on this planet unfolded under the watch of the same celestial vault. Fact 99. Future generations might see skies very different from those we observe tonight. The night sky feels eternal, but like everything else in the universe, it changes. Stars are born and die. Constellations slowly reshape as individual stars follow their separate paths through the galaxy. In the far future, collisions and mergers will blend galaxies together, fundamentally altering the view from Earth or wherever our descendants might live. Climate change and increasing light pollution threaten to obscure the natural sky for many people alive today. Cities expand, artificial lights multiply, and with each passing year, fewer people experience truly dark skies. What was once a universal human experience, the awe-inspiring canopy of stars visible to everyone simply by looking up at night, has become increasingly rare. Protecting dark sky areas and reducing light pollution helps preserve this connection to the cosmos for future generations. Technology allows humanity to explore space in unprecedented ways, but nothing replaces the direct experience of standing beneath a star-filled sky, feeling simultaneously small and connected to something vast and ancient. Fact 100. The night sky invites contemplation and reminds us that we exist within something larger. Looking upward on a clear night provides more than just beauty or scientific information. It offers perspective. Each point of light represents a sun, possibly accompanied by planets, maybe even life. The scales involved, both in distance and time, dwarf human concerns and individual problems. Yet rather than making us feel insignificant, this cosmic perspective can bring comfort. We are part of the universe, made from its materials, shaped by its laws, connected to everything else through billions of years of cosmic evolution. The questions the night sky raises have driven human curiosity and imagination for as long as our species has existed. Where did we come from? Are we alone? What lies beyond what we can see? These questions unite us, transcending boundaries of culture, language, or time. The stars do not provide easy answers, but they invite us to keep asking, keep exploring, keep wondering. As you drift towards sleep tonight, let the vastness above remind you that mystery and beauty surround us always, waiting patiently in the darkness between worlds. In the silent depths of space, in the ancient light of distant suns, still making their way toward Earth. Closing. And so, we reach the end of our journey through 100 facts about the night sky. Each fact is a doorway into something larger. An invitation to look deeper, to question more, to appreciate the extraordinary universe we inhabit. The stars will be there tomorrow night and the night after, patient and constant, always ready to share their light with anyone who takes a moment to notice. Rest well, knowing that above you the cosmos continues its ancient dance, unchanging yet ever-changing, familiar yet endlessly mysterious.